Since the beginning of 2016, Freiburg's Blue Factory site hosts the Smart Living Lab, a research and development center devoted to the built environment of the future, whose own building will be constructed on the same site in 2020. This groundbreaking construction will be called the Smart Living Building and will be both a sustainable structure and an evolving building, consisting of laboratories and offices for some 100 researchers. It will also offer dwellings. In this multiple-use context, the building will become an experimental field of studies itself in order to find solutions to energy consumption and the greenhouse gas emissions that it generates. The Swiss Federal Council has affirmed their will to move on to a 2,000-watt society in 2150, with a 3,500-watt intermediary stage in 2050. To allow the Smart Living Building to reach this goal, an interdisciplinary research program has been set up, financed by the state of Freiburg. Under the supervision of the Building 2050 Research Group, some 30 researchers from EPFL, HEIFR and Freiburg University are already pursuing a common goal: designing a model building for the future. By centering the research on the questions of energy and comfort, as well as architectural quality, researchers have identified 5 vital organs on which to work: the user, for whom the building is constructed; the building's envelope; local energy production or transformation; energy storage; connection with mobility. These vital organs are subject to 5 experiments. This experiment will allow measuring the comfort felt by users, experimenting different thermal inertia, lighting and ventilation scenarios. It allows, for instance, a better evaluation of bioclimatic strategies, such as implementation of rammed earth to increase the building's thermal inertia. The outcome sought here is to optimize the correlation between renewable energy availability and the building's energy demand by using the grid's energy at the moments when it's greener, producing renewable energy in situ, storing green energy to be able to use it when the grid is more CO2 charged, communicating with users in order to encourage them to plan their energy consumption at the hours of greatest availability of renewable energy. To reduce energy consumption and CO2 emissions, the aim is to obtain a stronger occupation density while satisfying the user's needs through partial desk sharing and by offering more common spaces. Through an increased intensity of use, the building's energy investment is thus more profitable. The research group has also settled a design assistance tool called ELSA. On the basis of an architectural intention, it enables the designers to manage a limited carbon and energy budget enforced for the building's construction. The tool uses a database of several thousands of conception alternatives with their respective performances, allowing an early integration of energy parameters in the design process. Throughout the project materialization decisions, the incompatible options are eliminated, guiding the designer through his successive choices. Interdisciplinarity and the experimental character of the project raise a parallel and reflexive approach, finding a common language for the whole chain of actors, from the researcher to the project owner. Which process will allow innovation, quality, but also performance? What roles and responsibilities must each of the stakeholders fulfill? These and other questions are to be answered by this experiment. These research studies, fed by the results of 2 workshops in 2015 and 2016, gathering international professionals and experts from the construction sector, will define the brief for the Smart Living Building's future designers. The Smart Living Building, a construction integrated into the city and meant to be a part of society's evolution, will be a true excellence centre, allowing to experiment a new lifestyle 30 years ahead of its time.